Okay, today we are going to be talking about inverse functions. If you'll recall from previous lessons, a function can be represented by a set of ordered pairs. So for example, if I have the function of f of x is equal to x plus 4, and I'm looking at the domain where x equals 1, 2, 3, and 4, if I take my x value of 1 and I substitute it back in here for x, I get 1 plus 4. So my corresponding range value or y value would be 5. If I substitute in 2 in here, 2 plus 4 is 6. And then 3, I would get 7, and 4, I would get 8. So my domain would be 1, 2, 3, 4, and my corresponding range would be 5, 6, 7, 8. So if I rewrote that in ordered pair notation, I would have the points 1, 5, 2, 6, 3, 7, and 4, 8. So let me plot those really quick. I've got the points. I've got 1, 5, 2, 6, 3, 7, 4, 8. So that's what it would look like graphed. So what would happen if we reversed the coordinates of this function? So if I reverse the coordinates of this function, instead of it being 1, 5, I would get 5, 1. Instead of it being 2, 6, I would get 6, 2. Instead of being 3, 7, I'd get 7, 3. And then instead of being 4, 8, I would get 8, 4. So all I did was reverse or switch my x and y values. So let's graph these. I'd get 5, 1, 6, 2, 7, 3, and 8, 4. All right, so when I look at these two things, this is my original, and this is the reverse. Does the reverse resemble the original relation? So here's my original relation right here. Here's my reverse. Well, it does. They do resemble. The original set is an ordered pair. I mean, it's a function, because if I were to draw my line, let's just say I drew a line right here, and I drew a line right here. My original would be a function because it would pass the vertical line test, where I only hit one point at a time. And then my new one would also be a relation because it would pass the vertical line test. So they're both functions, but instead of calling it reverse, we're going to use a term called inverse. This is the inverse of the original. So f of x is my original relation. F negative 1 of x is the inverse of that original relation. And they look very similar. They were both functions because they both pass the vertical line test. So let's go ahead and define inverse relations real quick. An inverse relation, so if we have an ordered pair, and it's written, this is just written in ordered pair notation, and it's in a relation. And remember, any set of ordered pairs is a relation. Okay, so the ordered pair AB is in a relation if and only if the ordered pair BA is in the inverse relation. Okay. So we have ordered pairs 1, 5, and then my inverse is going to be 5, 1. So basically, you are just flipping your x and your y values. All right. So in this lesson, we will be studying the connection between a relation and its inverse. And more specifically, we are going to be the most interested in inverse relations that happen to be a function. So we're going to go back to our example and our example that we worked with where f of x is equal to x plus 1. And we want to find, it's a function because it passed the vertical line test, and we want to find the inverse function. So this is my inverse function right here. This has an equation. My equation is f of x equals x plus 4. Now we want to find the inverse equation. That's what we're looking for, the equation of this relation right here. All right? So what we have to do is we have to think about what's been done to the original function. Well, we added 4. So the inverse, if you will remember, when we're solving equations, we are doing inverse operations. So inverse means undo. So we're wanting to know what operation undoes what's been done. Well, they've added 4. So to undo that, we subtract 4. So we have x minus 4. This is the inverse function. And this f of negative 1, that negative 1 just means inverse. So here's my original function. Here is my inverse function. So we were looking at the domain of 1, 2, 3, and 4. And when we entered those into our original function, we got a range of 5, 6, 7, and 8, and we came up with these ordered pairs. So my domain is 1, 2, 3, and 4, and my range is 4, 5, 6, and 7. So in my original function, 1 goes with 5, 2 goes with 6, 3 goes with 7, and 4 goes with 8. But in my inverse function, we flip the ordered pairs so that my x values become the y values and the y values become the x values. So in the inverse operation, 5 is my domain and 1 is my range. So it goes the opposite way. This becomes the domain and this becomes the range. Okay? The domain of the original function becomes the range in the inverse function, and the range of the original function becomes the domain in the inverse function. So a simpler way to express this is just to say the x and y values are reversed or switched. Okay? So let's talk a little bit about how to determine if a function and its inverse are both functions, because that's really what we want to focus on. We want to focus on functions, and specifically functions who have an inverse that is also a function. So before we do that, we were going to look at the graph of f of x is equal to, let me write this a little bit better, x squared. So this is the graph of x squared. It's a parabola, okay? And we know that it's a function because it passes the vertical line test. It doesn't matter whenever we draw vertical lines, it only passes through one point at a time. So this is a function. We know it's a function. Okay. Now this is the graph of the inverse of x squared. Okay. So it goes this way. This is the inverse. And I want to know, is the inverse also a function? Well, we don't use the vertical line. If I did a vertical line, I could see, well, actually we do. I do a vertical line and I can quickly see that it passes here and here. So it's not a function. And it's because it fails the vertical line test. So often we're going to want you to be able to look at an equation and determine, is it a function? And then determine, is its inverse a function? But I don't always want to have to graph it. So they have something called a horizontal test, a horizontal line test. And what the horizontal line test says is if you have a function, so this is my function, and we know it's a function because it passes the vertical line test. If I want to know if its inverse is a function, then I'm going to do a horizontal line test. So if I draw a horizontal line through the function and that horizontal line passes in more than one point, then its inverse is not a function. And we know it's not a function because we looked at it over here. But if I don't want to have to graph its inverse and do the vertical line test with the inverse, I can just look at my original function, and if it fails the horizontal line test, then its inverse is not a function. So the definition for horizontal line test is right here. The inverse of a relation is a function if and only if each horizontal line intersects the graph of the original relation at most one point. So let's do a couple of examples. All right, so let's look at, first, we want to look and see which of these relations are functions. So basically what we're doing is we're wanting to know which functions pass the vertical line test. So when I look here, this passes, so it's a function. This fails, so it's not, because it fails the vertical line test. This is not, because it fails the vertical line test. This is. It is a function. All right, so A and D are functions. B and C are not functions because they fail the vertical line test. All right, so now then, I'm going to go back and I want to know which relations have inverses that are functions. And so what we're looking for here is, does it pass the horizontal line test? So when I go here and I draw horizontal lines, am I passing more than one point? And it's not. So the inverse is also a function. All right, when I go to D, I do a horizontal line test, I can see that it crosses 2 points, so it is, the inverse is not a function because it fails the horizontal line test. All right, so example A, this example right here, where it's a function and its inverse is a function, is a special type of function called a one-to-one function. One-to-one functions, that just means that for any A and B in the domain of function f, f of A equals f of B, which implies that A equals B. I know that that may not make a lot of sense to you at this moment, but give it a second. We're going to practice a little bit, and it will make more sense to you. All right. So if we're wanting to determine if a function is a one-to-one function graphically, we're going to use the vertical line test and the horizontal line test. And if it can pass both, then it's a one-to-one function. All right? So that's how we do it graphically. It must pass the vertical line test. Well, let me be a little bit more specific right here. The original function must pass the vertical line test and the horizontal line test to be a one-to-one function. But you're going to start to get into some functions that might not be so fun to graph. So you're going to want to know how to determine if a function is a one-to-one function algebraically. And we're going to use this definition right here, where f of a equals f of b, so a equals b. So let me show you an example. We want to show that f of x equals 1/3 x plus 2 is a one-to-one function, and we're going to do this algebraically. Okay? So what we're going to do is we're going to use our definition. F of a equals f of b. I apologize for my dog, sorry. Okay, so if you remember, what's inside of here is what we substitute for our variable. So if I want to find f of a, I'm substituting a for my x. So I get 1/3 a plus b. If I want to find f of b, I'm substituting 1/3 in, I'm sorry, that's a 2. I'm substituting 1/3 in for my x, so I get 1/3 b plus 2. Now then, I want to solve to get, I'm looking to get a is equal to b. So I'm going to solve, I'm going to subtract 2 from both sides, and I get 1/3 a equals 1/3 b. I'm going to get rid of my 1/3 by multiplying both by 3, and I'm left with a equals b. So since I get a equals b, then this is a one-to-one function. Okay. Right. This will get easier, I promise. All right. All right, now we want to determine if two functions are inverses. And to do that, we're going to use the inverse composite rule, which says, let me make this a little bigger, f of g of x needs to equal if f of g of x equals x and g of f of x equals x, then the two functions are inverses. So we want to verify that f of x equals 2x minus 1 and g of x equals 1/2, parentheses x plus 1. We want to prove these are inverse functions. So what we need to do is prove that f of g of x equals x and that g of f of x equals x. And if those two things are true, then these are inverse functions. So let's do f of g of x first. So we're going to use the f function. And now then we're substituting in g of x for x. So I've got f g of x is 1/2 x plus 1. That's what I'm substituting in for x. And I want to show that it equals x. So now all I need to do is simplify. So I'm going to simplify inside my parentheses first. I'm going to have 1/2 x plus 1/2. Now I'm going to distribute my 2. 2 times 1/2 is x. 2 times 1/2 is just 1. And I can drop my parentheses. Now you can see that my 1's cancel and it equals x. So this does equal x. So that one works. So now then we want to try g of f of x. Okay, so we're starting with the g function. I've got 1/2. Now then for x, I'm substituting in f of x. So I'm really doing I'm really substituting in 2x minus 1 for x. So I get 1/2, and I need to put in 2x minus 1 plus 1. Now then, all I need to do is simplify and prove that I get x. So 1/2 times 2 is just x. 1/2 times -1 is -1/2. 1/2 times +1 is +1/2. Those cancel, and I just am left with x. But I guess even up here, I could have canceled those out and just multiplied there. But they both are equal to x, therefore they are inverses. Okay? All right. Now then, we're going to learn how to find inverse functions algebraically. So we're going to follow these steps right here. It is the same process every single time. We'll start with some easy ones, and we'll do easy ones on this video, and you'll do some easy ones in your homework, and then when you come to class tomorrow, we'll work on some more difficult ones. So the process to finding the inverse function is, in the equation for f of x, we're going to replace f of x with y. Then we're going to switch our x and y. Then we're going to solve that equation for y, and then once we have the y alone, we're going to replace the y with f of negative 1 of x, which just means the inverse. So I have f of x is equal to 6x plus 1, and I want to find the inverse of that. So the first thing it says to do is to change my f of x with a y. So that's step 1. Step 2 is to switch my x and y. So I want to switch these two. So I get x equals 6y plus 1. Now then, I want to solve for y. So in order to solve for y, I need to subtract 1 first. And then I need to divide by 6. Okay? And obviously, 6 won't go into that evenly. So this is step 3. All right, so step 4 is I get y equals x minus 1 over 6, and I want to replace that y with the inverse. Let me write that a little bit better. The inverse, and that's all we do. Okay, I'm going to keep them pretty simple for you today. All right, so let's do this one. My first step is to replace f of x with y. Then step 2, I'm going to switch my x and my y. Now I know that you're going to want to try to skip steps, but don't do that in the beginning. If you can take your time and do it step by step every single time, then you will know how to do it, and in the future it'll be easier to take shortcuts, but don't take shortcuts at the first when you don't know what you're doing, because you'll just get lost. Okay? Step 3, I am going to solve for y. Well, y is in my denominator, and I need to get it out of my denominator, so the way I'm going to do that is I'm going to multiply both sides by y minus 2. So I get x times y minus 2 equals 4. And now then I need to, I need to get my y alone. So I need to get rid of this x first, and then I'll get rid of the 2. This is x times y minus 2, and in order to undo that, you need to divide. Okay? Those x's cancel, and I'm left with y. I can drop my parentheses, y minus 2 all over 4x. Now then I need to move my 2 over, so I get y is equal to 4 over x plus 2. And now I can go to step 4, where I rewrite this as the inverse of f is equal to 4 over x plus 2. Okay. All right, let's try one that's a little more difficult. All right, so step 1, we're just going to replace f of x with y. Step 2, I'm going to switch my x and my y. Step 3, I'm going to solve for y. So I need to get rid of this 1/3 first. So I'm going to multiply both sides by 3. And I get 3x is equal to, this cancels out, and I'm just left with the cube root of y plus 1. Now I need to undo this cubed root. And the way I undo a cubed root is I'm going to raise both sides to the third power. Okay? This cubed root and raising to the third power are inverse operations, so they undo one another. So I am left with 3x to the third, which is 3x times 3x times 3x equals y plus 1. Okay, let me move up here. 3x times 3x times 3x is 27x to the third. Is that a 3? I'm so sorry, that's a 1/2. We're just going to change this right here to a 3. Okay, so I get 3 times 3 times 3 is 27. X times x times x is x to the third equals y plus 1. To get y alone, I need to subtract 1. And then step 4 is I'm just going to replace y with f of negative 1 of x equals 27x to the third minus 1. Okay. These will get easier when you practice, but it just is going to take a little bit of practice. So there's a couple of these for you to do in your homework assignment, and we will definitely be working a lot more with this when we come to class tomorrow. All right, so let's finish up. The last thing that we're really going to talk about is finding inverses graphically. All right, so here are my steps to do that. To determine it, first you need to determine if the inverse has a function using the horizontal line test. So I'm going to draw my horizontal lines, and it's only going through one point. So this does have a inverse that's a function. So then the next thing that we want to do is it says we want to sketch this line of y is equal to x. So to sketch that, y is equal to x has a y-intercept here at 0, and it has a slope of 1. So this is what my y is equal to x line looks like. Okay, so I'm just going to draw a dotted line in red. Then it says, so you're imagining a mirror that's just, we want to mirror this image. So now then what we're going to do for my inverse is I'm going to take points that are on the graph and I'm going to reflect them across this imaginary y is equal to x line. So what I do is I find some points on the graph. I've got a point right here, and it looks like I have a point right here, and it looks like I have a point right here. Is that right? Oh, I've got one right here. This go over to, let's see if I can find another point. All right. And you're going to just kind of have to estimate, since this isn't the best of graphs. So I've got some points in green. What I do is I write them out as ordered pairs. So I've got -2, -4. I've got -1, 0. I've got 0, 1. I've got 1, 2, and I've got 2, 4. That's my original function. So the inverse function, I switch my x and y values. So I'm going to have -4, -2, 0, -1, 1, 0, 2, 1, 4, 2. This is going to be my inverse function ordered pairs to graph. So I'm going to go over to -4 and down to -2, and I'm going to put a point. I'm going to go to 0, -1 and put a point. 1, 0, 2, 1, 4, 2. So let me clean up a little bit right here so it doesn't look so busy. All right, so now then I'm going to draw my line, and it's going to look something like this. And if I were to hold up a mirror along this x equals y, it would look like a mirror and mirror image of one another. All right, So this is going to take just a little bit of practice. All right, so let's try another one. All right, so we want to draw the inverse function of this function. First, we need to see, does it have an inverse that's a function? Well, when I do my horizontal line test, it only goes through one point at a time. So it passes the horizontal line test. All right, so then the next thing I want to do is I want to draw my imaginary y is equal to x. And that's where these red dots are going to be. Okay. Then I'm going to find a few points on my original graph. So it looks like I have a point right here. I have a point right here. Got a point right here. All right. So I'm going to find some ordered pairs for this. All right, so I've got, it looks like I've got -2, -1. And I'm going to go right here. I've got 1, 0. I've got 2, 1. Oh, I guess these are going by 1/2. So let me change this. This is actually -1.5 right here. So I've got 1, 0, 2, 1. 3, 2, and I've got 5.5 and 2.5. Okay, so now then my inverse function, I'm going to switch my x and my y's. There's something about visually just writing this down so you don't make mistakes. So now then I'm just going to plot, I'm going to go over to -1. And I'm going down 1.5, which is about right here. I'm going to go over 0, 1. I'm going over 1, 2. Going 2, 3. And I'm going to go over 2.5. I can't get that. I can't get this point on the graph that I have, but I can. Okay, so I'm reflecting. Let's see, here's this. I can look and see. I'm still trying to figure out. I'm looking right here. I've got a point that's like 1.25 this way. So that means it's going to be 1.25 that way. So I'm going to have a point that's about right here. I've got a point that's 2 this way, so it needs to be 2 that way. I've got a point that is, okay, so I'm going to draw my line. I feel like that's not right. Oh, because I went over 1/2. This is my problem right here. It's this point. I'm a little off because I'm not going, this is 1/2 right here and not, okay, so let me redo that again. I've got -1 and 1.5. Okay, so I can't really get this point on there. Okay. So I'm going to do, I've got 0, 1. I need to do 2, 3. That's right. And then 2.5. Okay, so I still need a few more points to help me figure out. So let me try to find the mirror of this one. So this one is 2, so this one's going to be 2. All right, so I go, there we go. It's a little bit of an art. You got to practice a little bit. I'm not very good at it either. All right, so let's do the one below it. I'm looking for, it is a function. This is a function, and its inverse is a function. All right, so I need to draw my y is equal to x, which is represented by the red. I'm going to find some points on my original. I've got 0, this is a radical function, so I've got 0, 0, 1, 1, 4, 2. So I've got 0, 0, 1, 1, 4, 2. My inverse points are going to be 0, 0, 1, 1, 2, 4. So I've got 0, 0, 1, 1, 2, and I'm barely going to be able to get 4 on here. Okay, but that's going to be my inverse. All right, so we will be practicing more of this when we get into, when we come to class. So good luck, enjoy your homework, and I will see you tomorrow.